Okay, so in this video, I want to try to help you guys to make sure that you can solve anytime you run into an overconstraint. So what is overconstraint? It's pretty much just as the name states, whenever you put in too many constraints or dimensions, then it locks the figure out. So the sketch no longer has, the logic no longer makes sense. You're telling it to do two things that don't add up. Now, what do I mean by that? You see this sketch, so it shows right here, sketch is fully constrained, so it has everything. All right, everything is how it should be. Now I can quickly make it overconstrained just by adding a dimension right here, and I get 2.2. Okay, and then you see now these have all lit up. I get a big message that says sketch contains conflicting constraints, and which usually means it's overconstrained. Okay, it's pretty much the same thing, and you notice all of these things light up red. Everything that lights up in red is what you're going to have issue with. Those are the rules that don't make sense. Okay, so really the big issue will be these three, but you can also notice that also highlights these. All right, you notice it'll highlight constraints along with dimensions. So whenever it tells you sketch has conflicting constraints, it's considering both the actual constraints from the constraint command and actual dimensions. Okay, it takes them both as the same thing. What it really is saying is that you have rules that conflict. Now, let's go ahead and talk about that a little more. Let's go ahead and delete this and problem solved. So the idea is this dimension right here, the distance from here to here, is already told implicitly. So you have to, there's no other value that it can be except for 2.2 because you have this distance right here. And since this has to be locked to here, it's very simple to solve for it. So we know the distance from this edge to the center is 4.2, and we have the length of this shape to be 2. So that means this missing space right here has to be 2.2. So really it's just a very simple algebra equation, right? 4.2 equals 2 plus x, solve for x. And that's very simple to do. And that's what nx is doing whenever you dimension something like this. That's why you don't have to have every single aspect of a sketch constraint, because it figures it out based off the geometry and the rules you have in place. All right, so when you have something like this, it's now overconstrained. Now I see if you look up here, you have that sort of exact same image, but it's not overconstrained. This is the point in the video where you should be asking why. So we have the distance from the top to the bottom as 1.5, the distance of this length as 0.5, and the distance of this as 1. Yet we're still fully constrained, but we have no issue. Why is that? Well, it's because this part right here, this cut. So if it wasn't for all of the other dimensions that we have in place, technically this doesn't have an angle to it. So if this rule didn't exist and this rule didn't exist, this little section could be tilted. It could have a different angle, and that would still imply the same dimensions here, because you'd have to define the new angles and all of that. Okay? I think we can overconstrain it if I just add a dimension right there. Yep. And now all of these, so you see how these two rules are the ones responsible for making sure this is in check. They cancel out. So if I delete this one, it should be good to go. Okay? And then let's put that back, because it's weird to define the angles like that, I think. But that's personal preferences. That's how you want to do it. That's how you want to do it. I think it's really weird. Next, we're going to go ahead and talk about constraint things. So if you can see, I have these set so that they're collinear and they're equal. So this one's 0.5 and this one is also 0.5. All right, and you can also figure it out mathematically too. So the total length is 2, this length is 0.5, and this length is 1. So 2 minus 1 minus 0.5, and that is 0.5. Okay. Now let's go ahead and try to mess with this one a little bit. So if I delete this sketch, sorry, I was taking a drink of water. So as I was saying, if I delete that dimension, and then now I'm left with this one, these two being equal and this non-existent, but still says the sketch is fully constrained. So what I have to do, if I put this, you notice now I have another issue because of this equal length constraint and this equal length constraint and these dimensions. So what we're saying is that line A must equal line B. No matter what, line A must equal line B. So if line A is 0.5, line B must also be 0.5. The problem is that when you have something like this type of dimension, you lock it in. You're just stating in stone, distance from this point to this point is 0.5 and it cannot change. The same thing when you have the equal length. This must equal this and it cannot change. So if I put in this one, NX does not automatically adjust this to visually represent the change in here. So if I tell this one that this must be 1, there's conflicting issues because the distance from here to here must be 1, but also the distance from here to here must be 0.5, which is fine until you get to the third rule. This distance must equal this distance. With all those three rules, we have an issue. So they cannot cooperate. And then we delete that. Oh, and for those of you guys wondering, when I was getting the water, I went ahead and added the equal length constraint here. I noticed I didn't have it. Now you see it's also locked in, but that's because of the math, right? This one must be 0.5, this line must equal this line, and this line must equal 1. It allows for no room of error, because if I change this to 1.5, now the distance 0.5 plus 0.5 plus 1.5 no longer equals 2. Instead, we have 0.5 plus 0.5 equals 1, 2 minus 1 equals 1. Okay? The very last one that I want to show you is whenever you have angles. So you notice in here I have a perpendicular constraint, and there it is with the right angle. What that means is that the distance from here to here is 90 degrees, right? Or the angle between here and here is 90 degrees. So if I were to tell it, you must be 90 degrees, what this really is saying that it can be anyone. It just happens to be 90 degrees. So I'm telling it to be 45. Now I have a problem because this constraint says it must be 90 degrees, but this dimension says it must be 45 degrees. Okay? And those are a little bit hard to fix because you notice this is done by the geometry, so all four of these immediately light up because this is going to be a huge change. And that should be everything that you need to know to cover. If you come into an issue of you don't know what constraint you're missing, so we see here sketch needs one constraint, what I would recommend doing is grab vertices and notice what moves as you grab them. Okay? So you notice it's this, right? I think that's more of a bad example because that geometry is highly linked to this distance right here. So this part. So let's delete this one instead. We should be able, yeah. So you see I can move it around. Now I have to move this point right here because this point to here must equal 4.2. So I can flip it around and go this way because the length from this point to the origin is 4.2. But I'm freely able to rotate this wherever I want to put it because I have no set distance of these two. If I were to dimension out this one, now I have a rule and I can't move the vertices. Okay? I can do the same thing for this one. It's just, yeah, like I said, with the angles missing, causes a bigger issue. And that should be everything that you guys need to be able to solve over constraints on your own.